Very good morning, teacher. We are from Group 3, and today we will present our mini project on the text generation for the natural language processing call. And the project focus on how machine can generate human like text. And now let's move to the next slide. Is the team member. There are 4 members in our group. There are me, David, Agusa, and Aichon. Now let's move to the next slide. Is the table of content that we will cover for the presentation today, and we divide it to 9 parts. Objective, step to develop the model, language model, evaluation matrix, result and comparison, text generation, challenge and learning, conclusion and future based on in the picture. Now let's move to the objective. To build and evaluate two language model based on the foreground. This model predict the network based on the clustering, and to use the model to generate meaningful text. And to achieve this, we focus on these key tasks, such as prepare the text data, building the model using two approaches such as the backoff and the interpolation, and evaluate the model using matrix called perplexity, and then we generate the text. Now let's move to the step to develop the model, and we divide it to 7 parts. The first one is the type selection. The second one is the type processing. The third one is corpus splitting and tokenized sentence. And after that, we build the foreground model and calculation the perplexity. After that, we generate text. And to begin with the data collection, we take the data from the Wikipedia API by installation the Wikipedia API, and then we provide the topic, and we give in the Python library, and we can program it only the article. And the process, we import the Wikipedia API library and then configure it and define the topic and fix the article using Python library. And now let's move to the data pre-processing. For data before processing, we cleaning the data set include the syntax, symbol, uppercase, etc. And after that, we clean the URL such as HTTPS or something else. And now let's move to the next slide. My team will continue with the presentation. Sorry, this for the corpus splitting. For corpus splitting, I use the Python library to clean and split the data, and after that, I clean the corpus into training, validation, and testing data, and split the text into the sentence and filtering the empty one, and then calculate the split for training. I use 70% validation, 10%, and after that testing 20% of the data set, and then sell the data set to the part. And that's all for my part. Let's move to the next part. It's domain view presentation.
Okay, my name is Hai Tongbai, and in this section we will talk about the tokenized sentence. And in we have the first step, and the first step is the tokenization. And the tokenization is the process of splitting text into the meaningful units. And in our projects, we tokenize and branding set into a video sentence. And in the second step is the define vocabulary. After tokenization, we define a vocabulary. To do this, we count the frequency of the word in the training data and select the most common word. In this ensure that our vocabulary size remain manageable. And in the third step is the handover. Words are not include the vocabulary. We replace with the unknown word that is represented by UN case, and it have our model and roles and understand word efficiently. And in the last step is the consistency across data set. And this transformation we apply the consistently to the training, validation, and testing set to ensure the alignment in data processing. And now let's move to the next slide. Is the building program model. And the next step in our project was construct a program model. This model estimate the likelihood of the word given the prevent trigger to capture more context compared to the lower order unground model. And now let's move to the backup method. The backup model enters data by using the highest order unground variable. This program sequence is not found in the data. The model backup to the trigram, and then to the bigram, and finally to a unigram. This hierarchical approach ensures that the model provides a probability for any sequence of the word. And next is an interpolation model. The interpolation model entails an n-gram probability estimation by combining the probabilities from multiple values, unigram, bigram, trigram, and fourgram, and exercise a way to each reward, ensuring that the final probability is influenced by the all n-gram reward rather than directly solely on one. And this makes the interpolation method more robust, especially then data is sparse. And for the both methods are powerful and quickly used in the natural language processing task. So in the next steps, let's move to Mr. Sam will be presenting.
Okay, thank you so much, Tomei, for your well explanation about the backup method and interpolation method. So, to evaluate our model, we use the perplexity, a widely used matrix in the natural language processing. So, it measures how well a model predicts a sample or sequence of words. So, in a lower perplexity score, it indicates a better model, and it also implies the model as a least complexity by the list of the data types. And here is our coding. We use the formulation as the lesson that we have learned so far. So this formulation helps us to evaluate the matrix. So we compare two models, the backup model and an interpolation. So after we calculating, as we can see, for the sentence in the token, we use the sentence in the token, and after that we use our program to manipulate or calculate our model. And the result shown that the interpolation model, they show the lower complexity, which mean it indicate a better result. And next, let's move to the text generation. So after we implement on our model backup and interpolation, after we cleaning the data, we come up with the text generation. So with the language model 1 and language model 2, we got a result. We got a result by generating what we have evaluated so far. And for our challenge and learning during the project, we focus several challenges, including cleaning and pre-processing the live data set, handling the raw data. However, we learned the importance of effective data preparation and also the balance between simplicity and performance in language model. And for our future work, we wish to explore the larger data set because we get the only data from Wikipedia. So we need to explore more and also experiment with the higher order of n-gram. Actually, in this exercise, we use 4 grams. So we wish to experiment with the higher order and also refine the smoothing technique. And after that, and next slide is our reference that we have researched so far, and let's go to the demonstration. Okay, so let's go to the demonstration. So before we start our project, we need to install some library, including the listed above. After that, we do the data collection. As we have stated earlier, we import our data from the Wikipedia API. And after we got the text, we do the data pre-processing, including the cleaning data, cleaning the upper text or the symbol or syntax, some syntax. And after we got the clean data, we need to do it is our corpus, so we need to divide our corpus into the 3 main domains, including for the trend 70% of the corpus for the trending, 10% for validation, and 20% for the testing. And when we run this result, run this splitting, so our total result of our sentence we got 356 sentence, trending set for 70% equal to 249 sentence, validation 35, and testing 72. After we split our corpus, we go to the next stage is tokenize sentence and limit vocabulary. So we do the tokenization and we count the vocabulary size, including the number of sentences in the trend token after the replacement, and we got the corpus, we got the unknown token. So which the word it show the list in our sentence, we collect it as our unknown token. So after we got all the result, we going to build our 4-gram model. So in the 4-gram model, as our teammate has mentioned already about the formulation of building the 4-gram model. So 4-gram model for backup, we had 4,537 entry, and 4-gram model for interpolation, we got 4,537 entry. So for building model for backup probability, and also we have built the model for the interpolation probability. And after that, we need to do the calculation of the complexity of each model, and we got the result by showing the interpolation model. It show the list number. It's smaller than backup, so we can make a conclusion that interpolation model it perform better than backup because it shows the result. And after that, we can generate our text. So over here, we generate by learning model, language model 1 and model 2, backup and interpolation, and we can run this again. Okay, after generating, we got the sentence. Khmer king were often involved in incessant power struggle over succession or rivalry over principality. And for our language model 2 interpolation, and need to make to the model system would have in our project presentation. Thank you so much, teacher, for your paying attention.
Cái làm vậy